Hello. I'm actually now continue in doing our pre-recorded lecture for week five, and this week five basically is our fifth classes on traditional database. The main thing I want to remind first at the beginning is for these particular classes, if you are actually from computer science background, okay, you are actually able to maybe not to say skip, but half of the material from this particular side may be familiar to you, okay, because we were going to revisit some of the traditional ways in relational database, how we are actually dealing with data and doing CRUD operation, including create, read, update, and delete. So if you are actually okay with your own experience in the database management, in a traditional way using relational database, as I mentioned just now, or like for example, you're very familiar with Oracle, MySQL, or you're using some other software, in your database management, then you're supposed to be able to catch up this lecture quite easily. All right. So let's start. So database management system is containing information about a particular enterprise, of course, because you want to collect data related to the company itself. Okay, so that's why it's a collection of interrelated data, set of programs to access the data, because database can serve like back end to actually store the information. For example, you want to create a student information system. Of course, database will become your back end to store the information about students, and the website itself will be like the front end for you to retrieve the relevant information from database and present it to the user. Okay, so in database management system, you will also have an environment that is both convenient and efficient to use. So you usually will have a back-end view, okay, for you to actually easily manage your data in a much more convenient manner. Okay, like for example, if you're familiar with MySQL, then you actually, if you are also use PHP before, then you actually have a very nice backend interface that helps you to configure a database. Okay. Then database application, of course, these are just examples, including banking transaction. In banking, include transactions, airlines include reservations or schedules, university includes registrations, grades. In so far, any system that you actually design, okay, actually designed to be used by the human for different kind of purposes, eventually you will need some sort of either big or small database to support it. Okay, so the database can be very large, because database can be very small as well. So it actually depends on the use case. But most of the time, okay, I wouldn't say all the time, most of the time, the database that we are mentioning at the moment right now is all based on relational database, rows and columns kind of database that we actually use most of the time. We don't really consider other type of data like image and text and so on. But of course, they are certain kind of software that we actually claim as like relational database focused like Oracle and so on. They start to accept different sets of data, like they can get unstructured, they can store unstructured data right now. But in general, this is what our understanding about traditional database. All right. So database touch all aspects of our lives, of course. Eventually, since when we are discussing like last week, okay, almost all all the data that we actually created, okay, model that we actually created is for human use and to store the information about humans. So that's why the database most of the time also touch all aspects of our life as well, right? So of course, we'll be actually discussing about a university database example, including application program in a bit detail, including add new students, instructor, and courses. Like when there are student registration, of course, you need to add new students. When there are new instructors that join the university, you need to add instructors, and new courses to be offered by the university, then you'll be needed to add over here as well. So this one, again, all these use cases are mainly based on how your system is designed. Then you have registered students for courses, generate class roster. So these two is after you have these basic information about students, instructors, and course itself. Then for one particular semester, who are the students that actually enrolled to these particular courses? who is the instructor that is going to teach these particular courses. This is how you make this information link together. Okay, so in here you'll be able to see, or from here you'll be able to see three different classes. Okay, and then you have actually the four classes to actually link this particular session. Okay, and then you can have generate class rosters, you have assign grades to students, compute grades, and generate transcripts. So all these are a very close functionality that a university's database is supposed to be able to achieve. So the database you will be also designed based on the nature of this particular needs, okay, for this software. So that's also the reason why if you're just studying the database concept itself, when we are actually in study in computer science background, then you know that it's actually a 14 weeks classes, and we are just doing a 1 week quick go through. And I believe that means if you are actually doesn't have any experience at all, I would strongly suggest you to really go online and check some information that's related to it. And yeah, which is we're gonna be very helpful for you to get the exact idea how database is supposed to work. So in the early days, database applications are built directly on top of file systems. I mean, on top of file system means like you are actually having certain kind of files stored inside your, the file system, you actually look at it like in your finders or in your file explorers. Okay. Then, drawbacks of using file systems to store data. Okay. So you have data redundancy, you have inconsistency. So you have multiple file formats, duplication of information in different files. So when you are storing in using legacy ways, okay, so when you are actually having redundancy at one point that, okay, this particular file A should be storing in folder A, should be also storing in folder B because they are actually having that particular characteristics over that. But in that case, you'll be actually introducing redundancy because the same file in two different folders, okay? In two different folders if you are actually having a good management system, you just need to save one file, but you are able to add text or add, certain kind of ways to tell that, okay, this particular file having two different properties that under those the original folder that we mentioned now. So in that case, you will be able to reduce the redundancy and also inconsistency over here. Because redundancy is explained just now, but inconsistency, the main thing here is maybe, unfortunately, when you want to update this particular file, okay, you remember to update in one folder but forget to update another one. Then in that case, you're gonna have version clash at that point. Next one, difficulty in accessing data. You really need to write a new program to carry out each new task. So at one point, when you are actually having files in different kind of folders, maybe you actually put it in a very formed way. But in that case, how are you able to access the data? Okay, of course, in general, we are actually double clicking in different folders and then double click and then you open the file. Okay, you can see the file itself. But if you want to do certain kind of crude operations, okay, for you to access files in different kind of file folders in this particular file systems, then you can imagine that you need to go to CMD, your control terminal, and then you need to write maybe a simple for loop for all the files in this particular folder and this particular folder. You need to execute this so-called program or task. Okay, so when in that cases you'll be needed to write a new so-called new program over here to actually do modification on the data that you are storing in the file system itself. Then the third one, data isolation, multiple files and formats. So this one is actually because you can store in many formats. So in that case, you will need to have the reader to actually able to understand that particular format. So else basically, you actually having isolation between different kind of formats. Like example, if you don't have a PDF reader, you won't be able to open a PDF file, right? So in that case, how many how many reader that you actually need to install? For different kind of formats that we actually have. Okay, and the last one, integrity problems where over here you are actually having like integrity constraints. For example, account balance bigger than 0 becomes a buried in program code rather than being stated explicitly. hard to add new constraint or change existing one. Okay. For this one, I believe this thing. Oh, I'm being a bit old. Forgot what does it mean really. Becomes buried in the program code rather than being stated explicitly. Oh, maybe it's because this one is actually one of the important criteria. Okay, important criteria as in the particular how should I say this particular so-called rules. Okay, supposed to be very obvious to the user itself, but over here the explanation become buried in the program code means that whenever you are actually accessing the data that you actually have in the files in the file system itself, you basically need to write a certain program, right, as it mentioned over here, to actually read the data. So all the checkings that you actually do, like those consistency check or credential check. So it's actually, for example, this one is actually fall inside. Sorry. Uh, Rachel. Oh, it's actually fall inside in your particular program code. Okay, but when we are as a user, account balance must be bigger than zero is something that we want to know. For example, yeah, it's actually something crucial. Of course, this example is not so, not so good. Maybe there are some integrity rules that is actually you might want to take note. For example, oh, I want my account balance to be always more than 100 ringgit. Okay, in that case, right, there is actually a rule over here. But this rule, when you are actually storing using file systems, you be needed to write this particular rule within the program code, rather than you are actually able to see these so-called rules in a clear manner. Because in database, right, we can actually define rules. Okay, define rules to retrieve the data that we actually wanted. Okay, in that case, and also it's very difficult for you to hard add a new constraint or change the existing one because all your rules are based on file folders. Okay, like okay, you create these file folders and then you are actually having name it to certain kind of concept, maybe some similar to some trees. So in that case, if you want to add new constraints, okay, you need to find the places that that particular constraints, right, is also achievable. Is also inheriting those other constraints that's up your parent folders. If not, then you can't put in this particular branch, you need to put in some other branch. So when your so-called folders becoming more and more, it's very hard for you to somehow add new constraint or change the existing ones. Because this is how where the file system is actually redundant at one point as well. So this is the integrity here means. Atomicity of updates. So failures may leave in database in inconsistent state with partial updates carried out. So this one, transfer of funds from one account to another should be either incomplete, should be either complete or not happen at all. So you need to imagine this situation. The database is actually able to do this kind of transfer, okay, like this fund transfer. They will make sure that this particular process, okay, this particular process will be executed all together. Okay, if partial of this particular statement is not executed successfully, so then the rest they will not execute as well, or they actually roll back to the original state. Okay, why is it important? It's actually over here the crucial part. Transfer of funds. Imagine you have 500 ringgit and your friends have 300 ringgit, for example, and you want to transfer, 300 ringgit to that particular friend. Okay, so you basically need to minus 300 ringgit over here, so you get 200 left. And in the process of transferring, okay, if you are using file system, maybe you can imagine the process is okay. And here in my file, I need to this particular person A, I need to minus 300, and then following by, you need to plus 300 ringgit to this particular friend. If there are data failure during this particular, like maybe just a few seconds, that particular data failure will make that this 300, this transaction is not completed, but the original 300 ringgit is already get minus by this particular person A. Then the friends of person A don't receive the 300. So the 300 gone. You see how crucial it is. I'm just talking about in a very simple kind of scenario. if that particular scenario is much more huge in funds or much more complicated in terms of transactions, so that will become a disaster. So that's the reason why atomicity updates here basically refers to how are you able to make sure that this whole chain of transactions, for example, is able to execute all or none of it. Okay, so that's the reason why over here, complete or not happen at all. Then concurrent access by multiple users. So concurrent access is needed for performance because when you are actually having databases, eventually you can't avoid from multiple access from different kind of places. But unfortunately, in terms of file folders, when you're accessing it, if you have experience in using Dropbox, then you know. When somebody is accessing it, another one can still access it, but just in case that somebody like person A edit halfway but haven't saved, then person B edit halfway and then save it before person A is actually saved. So in that case, you basically have somehow like a duplicate version at the end of the day. Then your Dropbox basically clash somehow. You see something like a conflicted copy. But this is what we don't want. Because why? If it's in the transaction point of view again, if you check on this one, two people reading a balance, say 100, and then updating it by withdrawing money, say 50 each at the same time. So your balance account is 100. You can withdraw 50. You can also, person A can withdraw 50, person B also can withdraw 50 because they share this particular account. If they execute together, okay? If they execute together, technically, it's still possible, right? A person withdraw 50, B person withdraw 50. So, okay, balance is 0, so it's fine. How about if your bank account is actually 100 and then you want to withdraw 60 and 60? How about that particular bank account balance supposed to have a 10 ringgit, okay? That is not supposed to be able to withdraw by anyone. You have a minimum amount, that so-called 10 ringgit, to be stored within that particular account. So if you don't have this kind of concurrent access, control concurrent access, okay? If you don't really control it, okay, and then you just let it go in this way, you'll be have this kind of troubles. And it's very crucial, again, when you are facing in financial sectors. You have problems like over withdrawing, more than the amount of balance that you actually have. So that's the reason why when you're doing banking kind of software, if I'm not sure you tried before, if you try to log in, for example, your maybe CIMB Bank or Maybank or any bank, I believe any banking solutions, if you log in your mobile phone applications, I believe if you immediately log in another mobile phone, or maybe you can't log in two mobile phones, but you try logging in browser website, browser in the laptop. So I believe that your mobile version will be immediately locked out because they don't really able to let you do concurrent access at one point. Okay, but there is a possibility that concurrent access is needed in your particular company. So in that case, how are you able to just control that? Okay, concurrent access, maybe just read. If you have write the things that you want to really write or edit, okay, how are you able to make sure that it's controlled? Okay. Then security problems, hard to provide user access to some time. Okay, hard to provide user access to some but not all data. So this security problem is a bit abstract because it depends on when you're actually having the file folders. A data is already there. It's just that you need to do certain kind of processing, I believe, or else all your files is actually standalone. Okay, so if you want to look for the information that is actually interested, or you want to process further on that, you need to open it one by one, find it, take it one by one, and then you put it back to maybe your own files and so on. But database will be able to assist you in terms of this kind of holistic view of all the data that you actually have. Okay. So that's the reason why we have 1, 2, 3, 4, 5, 6, 7 drawbacks over here, because the database system compared to file system, will be able to offer solutions to all these problems. So there are many different data models. So the main thing that we're gonna be looking at is entity relationship data models. Okay. Of course, if you want to use object oriented, it's also almost fine because these two, I believe these two is actually, in my understanding, is almost the same. Okay. But of course, there are differences. Okay. But the rest of the thing, maybe if you're interested, then you can go and take a look on it. But the relational model over here is the one that we are discussing because this one is actually the most standard way. Okay, entity relationship diagram, of course. Data model is of course it's like the extension to the relational model. That's why I'm saying that this one is the one that we focus on because it's like the most basic graph that we will need to draw. Okay, when we are actually learning in the database class. Okay. Then we start explaining this. So from this, from slide 7, I will quickly scroll for a while. Okay, from slide 7 to slide 22. If you have already know about legacy database, how it works, right? You can skip from 7 to 22 because these are all examples that is actually based on the traditional database point of view in terms of using CRUD. Okay, then you can directly go to the last few slides, like 33 and onwards. Okay. So relational model, all the data is stored in various tables, and then the example of tabular data is in the relational model, including you have columns and rows, and there are specific names, which is attributes. There are many other names as well, but we'll be using attributes and tuples in here. And then a sample relational database can look like this: have instructor tables, have departments table. So it's the same example that we have talked about just now. Then you have keys. Okay, so that key is actually a subset of R. So you notice that there's actually a lot of this kind of algebra, but let's follow and see what's the meaning of it. So K is a superkey of R. If values of K are sufficient to identify a unique tuple for each possible relation R. Okay, so ID and ID name are both superkeys of instructor. Why? ID together with name are both superkeys of instructor because you are able to uniquely identify tuple for each possible relation, which is when you use this particular column only, you'll be able to uniquely identify all this information. Same goes to when you're using a couple of ID and name, which sometimes we also call it like composite key. Then, superkey is a candidate key if K is minimal. For example, ID is the candidate key of instructor. So you can see a difference over here. The ID over here is actually a candidate key because it's smaller in terms of numbers. Then one of the candidate key is said to be a primary key. Which one? So in here, ID can be the primary key. Of course, if you want to use composite key, it's also fine. But usually, if your ID is already able to make it like a primary key over here, you don't really need to add another one more name over here because you basically introduce redundancy as well. Then foreign key constraint. Value in one relation must appear in another referencing relation, reference relation, or for example, we have department name in instructor, department name in your instructor table, okay, here, is actually the foreign key from instructor referencing department. Instructor referencing department. Okay, you get the meaning? This whole part of the department name is actually referring department from instructor. Sorry. Yeah. From instructor referencing department, yes. From instructor referencing department. So basically you refer to department to get all this department name, which is over here. And then you have schema diagram, but again, as I mentioned previously, maybe you learn about entity relationship, which is fine as well. Like all these like underline is primary key and also foreign key. Then you have an SQL relation is defined using a create table format, which is create in this way. Usually, if when you go back to the example directly over here, is create is your reserve name, and then you are creating table, so table is a reserve name as well. Instructor is your table name eventually. Okay, that's why it's create table R. Then you have AD1, A1, D1, A2, D2, AND. What is this? It's actually N as well, I think. Okay. So means that every time when you are creating a column, okay, or what we call attribute, you need to tell the data type of the attribute. So that's the reason why you are actually having attribute and data type. A1, D1, A2, D2. All right. So it depends on how many you want to create. So over here is showing you 4, and then you can use char, varchar, numeric, and so on. Okay. If you want to know more, of course, you can go and check what other data types is acceptable within a database. One thing that I didn't tell is integrity constraint. But integrity constraint mainly is telling you that, okay, maybe you want to in here directly create that ID is actually primary key. Then you can actually put in integrity constraint over here. Then update the tables. You can, after you create the table, the table content is actually empty. So you need to insert the new tables, okay? Or remove all the tables that from the student relation because maybe you insert it wrongly. Then after you delete all the information inside your table is still there. So how are you able to remove the table? Drop the table. And the last one, if you want to change your structure of the table, for example, you want to change the attributes, okay? Change the attributes. So it's either you want to alter table, add A and D, okay? So you notice that A and D is actually the attributes and also the data types. So if you want to add new attributes, then you actually can put in the A and D over here, then you are able to add in the new one. How about if you want to remove a whole column? Then remove is easier. You just need to alter table R, drop the attribute. But it depends. But over here it's actually mentioning that dropping attribute is not supported by many databases. But I think it's droppable, possible to drop. Then this is the one important thing that it's like an introductory SQL statement that you must know. Select attributes. You want to select one attribute or 3 attributes or all the attributes. It depends on you. Then you have from. Which table you want to come from? Is it R1, R2, or all the tables that you have? Where P is your predicate, or also we sometimes explain as a condition. What kind of condition you want to follow in this particular attributes that you are selecting, so that you will only retrieve those tuples that fulfill these criteria. So the select example over here, we are actually getting a select cost list attribute desired in a result query response to the projection operation. But of course, we go to the example, then we know that select name from instructor. What is your instructor table? Instructor table is this one. Select name from instructor, so basically you return all this. Okay. Note, SQL names are case insensitive. So even your table is actually instructor in the capital letter, and then you put it as when your SQL statement you're writing as a small letters, then you still be able to get the same outcome, right? The where clause specify the condition, so you notice that these first 2 lines is the same, but where department name is ComSci, okay? ComSci. So if you execute this table, before they are retrieving this one, they will also do a checking where all these names, which one is having a department name of ComSci, and ComSci over here. So in that case, in the end of the day, only three students, only three instructors that is fulfilling this criteria. So in the end of the day, your return result will be CATS, Srinivasan, and Brandt. Okay, same goes to this one. Comparison result can be combined using a logical connectives and or and not. This one, select name for instructor where department name is ComSci and salary more than 80,000. So this is even further. You can actually use N to have a lot of different kind of rules that you want to create. So in that case, let's go back. More than 80,000, right? After we decide that it's actually ComSci, and ComSci, you want to have identify who are actually earning more than 80,000. ComSci, the first one is 75, no. And second one, 65, no. The third one, 92, yes. So right now you only left one answer, Brandt. Okay. So this is the where clause. From clause is actually lists the relationship involved in the query. So that's why just now we are actually having, we are actually having all, okay, we are actually having all the information within a table only, which is instructors. But right now, if you want to have cross, okay, you want to really, like, for example, show every single information within a table, then you actually can put select all from instructors. Then you are getting this one. Then you actually have select all from teachers. Then you get this one. But if you want to have a Cartesian product, okay, Cartesian product as in if you just having this one, means that you will actually have this table joining with this table all together and then showing this. Take an example here. So this one is Srinivasan, computer science 65,000. That is first line, right? Then it will join with exhaustively with all the outcome over here, which is 1, 1, 1, 1, 1. Okay, everything is exhaustive. So in that case, you notice that this one, and this one link together. This one basically link 1, 2, 3, 4, 5, 6, and then you get this 6 outcome. Then the second line, 1, 2, 3, 4, 5, 6. Then that's why you get the next 6 outcome and so on. But do you think this one is meaningful? Technically, it's correct, but it's not so meaningful because you don't really, put in the relevant information within this particular table. Because if you put in this way, even though you have known that the institutional ID from the instructor is actually this one, but teachers.id over here, which is supposed to be the foreign key from here, you don't really do those important comparisons here, where even though your instructor is Srinivasan, we already know that, but the teacher's ID over here is actually contradicted here, but you still put it in this particular Cartesian generated table, which is less making sense. Technically, you're supposed to do a where clause as well. Then you compare institutional ID equals to teacher's ID. Then you'll be able to filter out these noises. We'll actually say that noises because it's nothing to do with Srinivasan actually over here. Then you get just 3 outcomes. And for example, in this one, if you also do the same process, then you know that it's only this one outcome because 1, 2, 1, 2, 1, checking in 1, 2, 1, 2, 1, this is the only correct responses or instances, and the rest will be discarded. This is how it's supposed to look like. Instructor ID equals to teacher's ID. And find the names of all instructors in the art department who have taught some courses and also course ID. So this one, another example, you have name, course ID, instructor table, instructor table and teacher's table. So this one, you have one more rules, which is only from art department. That's why you do an and clause over here, and you will get instructor.department name equals to art. So you will only show those art student, arts lecturer, right? So here comes the modification. When your data is actually not to say small, but data modification is crucial in your system. For example, you have students in and out or changing information, and then you actually have like instructor is in and out or changing information as well. Then modification in the database is actually quite crucial. There is a situation where modification of the database is not crucial, and that's the reason why modification functionality can be like closed or deactivated. For example, in Hive, okay, Hive in general they don't allow modification in the database because they believe that given a big data, okay, it's better that you retrieve a new set of data if you know that your data is having some issues, rather than you go and modify the data within the retrieve intermediate data that you have. Okay, it's better that you go back to your original sources, and then retrieve a new set using your new rules. So, but still important for you to know what the modification over here means. So you have deletion. Okay, so given the relation, you perform deletion, then the whole line will be, or whole rows will be deleted. Then you have insertion of new tuples. Given that you follow exactly the attributes that are actually given to you, and then you also have updating of values in some tuples in a given relation. Again, once you're given the relation and the relation is accepted, then you can replace the information inside. Then you have deletion. It's either you want to delete all instructors. Okay, you basically when you execute this one, you don't really delete the table. Okay, but you delete all the tuples within the table itself. Then it's either you want to delete from instructor, but department name is from finance. So you basically any data that is having a department name as finance will be deleted. And it's either you want to delete the tuples in the relation with instructor also associated with a department located in Watson building. So you want to check delete from instructor where department name in, select department name from a department where building equals to Watson. So in that case, you need to do the nested over here first. Select department name from department where building equals to Watson. Select department name from department. Over here, select department name from department where the building equals to Watson, which is Watson and Watson. Okay, so you'll be selecting biology and physics. So to solve this one, this whole part will become, the outcome will be biology and physics. Then delete from instructor, this whole thing will become delete from instructor where department name equals to biology and physics. This is how the nested SQL statement works. Continue. Insert into courses, you need to put in values like 1, 2, 3, 4, or you want to put in the full course ID, title, department name, and credits. Okay, then they will know that this one match with this one match with this, and so on. But if you want to follow the default settings, then you can just type in this way. Then, or you want to add a new type of student with a total credit set to down. So in that case, you can put it inside the students. Then you actually have this ID and also green finance, but you want to have the total credits because maybe you don't have information yet, but you still need to create the data. You can put in now first, which is missing. Then increase salaries of instructors whose salary is over 100,000 by 3% and all others by 5%. So you want to increase salaries, right? So in that case, you have two rules over here, which is update instructor set salary equals to salary times 1.03. So you are basically having increment of 3%, where salary is bigger than 100,000. So this is one clause. Okay, and then this one is actually another clause. When you have actually update instructor set salary equals to salary times 1.05, where salary equal smaller than equals to 100,000. Why the order is important here? Do you know why? Okay, if like for example, if you put this whole thing roughly like this, upside down, what will happen? There might be some of the worker, right? get their salary increased twice, 2 times. Because why? If you're actually originally having salary lower than 100,000, okay, which is fine. Maybe you have 90,000. Oh, sorry, maybe not 90,000. Maybe 98,000. Okay, 98,000. Then you fall into this category, and then you times 1.05. Okay, you see 98,000 times 1.05. You got right now more than 100,000. If you have more than 100,000 right now, then when you execute this one, it's gonna be fulfilling this criteria again. Then basically you get another 3% increment. So one of your employee get 2 times increment. Which was supposed not to be this way. That's why the sequence over here is important. You need to execute this line first, then only execute this line for this particular example. So these are the quick recap. I don't really go into a very, very challenging one. I believe the most challenging one might be just this one, which is we are actually having a nested outcome. But if you want to learn more, I would strongly suggest you to go online and check some online material. There are a lot of material about databases online that you can grab. So I believe it's not that difficult for you to learn by yourself for this one. And I believe maybe some of you, maybe attending some other classes, they also touch a bit about database. Then you can catch up a bit more from there. Okay, so we are now go to the almost the end of the class, but we need to compare this kind of so-called traditional database. Okay, compare with something what we call as over here traditional file access. What do we understand by traditional file access over here? I think there's something from, I think there are some extra, no, never mind. Imagine you are actually in a bank, okay, in a bank. If you go to a bank, they will be always having a lot of big trays, okay, a big trays where maybe when you requesting some documents, they will actually go to all the trays. They basically take out all the trays, maybe following your information, including IDs and so on. So they locate the correct trace, pull it out, get the hard copy of it to attend to your request. So this is the thing about traditional file access, even more traditional than the traditional database that we are talking about. Okay, as in like a hard copy way for you to store data. What's the good thing and bad thing about it? The good thing, of course, data security. Because why? Somehow, only the authorized personnel will be able to access to that places that store the hard copies, right? So in that case, it's actually much more secure than the traditional database we actually have here, or even the Hadoop that we actually have as a so-called big data management. Example of the big data management, because anything digital is prone to attacks. So they can actually like hack your database and so on, or they want to destroy your databases. It's actually possible because it's all digital. It's much more achievable compared to the traditional file access, which is only able to access by authorized personnel. Complexity. This is also quite surprising because when we are designing a database, we want to make it as easy to be accessible as possible, right? But the thing over here is, even though how simple it is, you still need to go for training. Like for example, if today you are not a computer science student before, you have difficulties in understanding CRUD operations. Maybe right now you still at the moment so far so good. At the moment so far so good because I'm actually giving you some general examples only. When you go further and further, okay, when you go further and further, you will need to understand more and more about how a SQL server should work and how a SQL statement or query is supposed to write in different kind of situations. All this understanding on the knowledge needs training. But if you are storing using traditional way, even the untrained people will be able to access and manipulate the data because the data is just in hard copy, and then you just need to take it out. You just try to use a pen, just jot it down all the edit modifications and so on. It's much easier for untrained people to access and manipulate data because they just need to go there physically, look into the lab, look into the notes, then you can pull it out and you get that particular data. Okay, anyone can look through the alphabetized filing cabinet. So basically, this one is the one that I'm explaining just now. Okay, but locating and manipulating an electronic database information may require technical training. Like for example, what we are having just now, select statements. You need to know how to generate or write a correct SQL statement for you to get the actual data that you actually want to retrieve. But again, there will be always disadvantages. The main thing will be access time. Okay, because if you have a very large paper filing system, can take minutes or even hours to actually for you to get the file. Okay, even though it's easy to get in terms of the knowledge on getting it, but you might take time because maybe you have a lot of trays for you to search for. Okay, but if you know about the skills of SQL very well, then you can actually get the outcome almost instantaneously. Secondly, editing and communication. So traditional file systems are cumbersome because they do not allow users to easily edit files. Because why? Every time when you have a hard copy, you can only cancel it off. Maybe you want to have an initial on it and then you write some new thing. Maybe you want to use a pen or you need to use a typewriter. So eventually your paper space is getting lower and lower. I mean, you can't even get any modification anymore. But if it's a digital copy, okay, as long as you are authorized person, then you know that you are doing it in a legit way or correct way, then you can edit it multiple times as much as you want. Okay. The last one, the order of data. The data can get out of order easily because, again, it's easy for you to retrieve from this particular places by untrained people, and that particular untrained people is easy to mess up your whole order of data. Maybe they put it back, when you put it back, they put it into the wrong place. Then you will never able to retrieve it back, at one point. Because imagine you have so many of trays, maybe from A to Z, okay, so many files of trays over there. So one untrained people make a mistake to misplace that particular data, then for you to retrieve it back, you're gonna be sequentially check on all the trays that you have. So imagine that is a very, very tedious task. Okay. So right now, basically we're gonna be wrapping up. So characteristics of existing electronic database over here. You can clearly define the fields organized in records. Records are usually stored in the tables, and fields have names. Relationships are defined between different fields. So you have schemas. Most of the time, the schema is referred to this one. Schema diagram. That the requires data to be validated against a schema before it can be written to the disk. So this one is like a draft. Okay, you can create a draft. Then only you check whether it's okay or not. Then you have requirement analysis, design, and so on. So this one, you'll be go to another subject will be which is called system analysis and design. Is your database correct to be designed this way? Okay, and then a design to get data from this to load data into memory is processed by applications. So this one is actually just trying to tell you that it can be inefficient if you actually want to load the database as is. And of course, there are still other characteristics you can look into it. This is a main message that we want to bring today. A part of all the comparisons with comparison with file systems, okay, and also traditional file access. And the third one, as the title, the traditional database that we have been discussed for a number of slides in here. We have already studied about HDFS and Hadoop. Right now, we study about RDBMS. Of course, maybe some of you have already studied before. What is the major difference? And how do you decide when to use which one? That's the main key point that you're supposed to be able to differentiate right now. to decide, okay, whenever in different kind of scenario, which one, RDBMS or HDFS, or even if you want to take in more like even MongoDB, which one is actually more suitable in your particular use case scenario by justifying using different advantages and different disadvantages of the software that you are focusing in. So, concluding remarks. So this lecture eventually is going to be quite, I believe it's going to be quite short. The first thing is. Second thing is just let you to know a few if you doesn't know yet, okay, how the database looks like, how to retrieve and update data inside a traditional electronic database using SQL language, okay, and comparison between traditional and modern electronic data access, and between traditional electronic database and big data database is discussed. So mainly these two. It's something like a revisit, okay, if you are computer science students, and if you are not, it's something like a very quick go through on how traditional database works, and try to compare with the HDMS or Hadoop that we have learned a few weeks back. What is the pros and cons in what kind of scenario? Okay, so these are mainly the lecture part. So that's all for the lecture part. Thank you.